So we want to find the acceleration of a cannonball that shot out of a cannon at an angle of 40 degrees relative to the ground. So what we're first going to do is just write an equation for the net force, which we need to solve for the acceleration. So as we can see here from this diagram, we have the force due to the cannon that's propelling this cannonball forward, but we have to subtract the force due to atmospheric pressure as well as the force due to gravity. So for the force due to gravity, we can't directly use m times g because it is traveling at an angle. So what we want to do here is we only want to take into consideration this horizontal component of the gravitational force. So what that will be equal to is mg times sine theta. So that'll be the force due to gravity going along the horizontal axis. So now we can write out this equation for the net force in a bit more detail. So the force coming from the cannonball or from the cannon itself, that's going to be equal to the pressure built up in the cannon, 7 megapascals, times the cross-sectional area of the cannonball. And we're not given that directly, but we do know that the diameter is 0.15 meters. So for the area, we can simply plug in the area is equal to pi times the diameter squared divided by 4. So this is what we'll use for A, the area in this expression. And we're going to subtract by the force due to atmospheric pressure, which is the standard atmospheric pressure, 101 kilopascals, times that same cross-sectional area of the cannonball. And not to forget gravity, we'll subtract mg times sine theta. So using, for the gravitational acceleration, 9.81 meters per second squared, we now have all the values that we need to solve for the net force. So when we plug in, what we're going to get is a value of 121.87 kilonewtons. And we know that this net force is equal to the mass times the acceleration, which we're looking for. So we simply rearrange to solve for A, which gives us the net force divided by the mass. So when we plug in the values that we know, and we know that this cannonball is 5 kilograms, what we'll end up getting is an acceleration of 24,374 meters per second squared.